continue from here. So 3 layers. Alternative physical state nu maakumbodhu how they are arranged. The crust is in solid state. The asthenosphere is in molten state. The mantle is in solid state. The outer core is in a molten state. And the inner core is in a solid state. So there is an statement. Earth crust is made up of alternative layers of solid and molten state. Now that answer is true. இல்லையா பாக்குறதுக்கு கன்வின்சிங்கா தெரியாது நமக்கு கிரஸ்ட் மேண்டில் கோர்னு படிச்சிருப்போம். கோர் மட்டும் தான் மால்டன்ங்கிற ஒரு ஐடியா போகும். பட் கிரஸ்டுக்கும் மேண்டிலுக்கும் இடையில ஆஸ்தனோஸ்பியர் இருக்கு. So there is an alternative arrangement of solid and molten layers. Earth crust, right? So இதுல இன்னும் 2 கான்செப்ட் மட்டும் பார்த்துட்டு we will move into the sources. Sources எப்படி ஹெல்ப் பண்ணுச்சு earth interior படிக்க. That is discontinuity. Discontinuity is described as the zone of transition of 2 layers characterized by change in the speed of seismic waves due to density variation. The definition discontinuity என்ன discontinuity 2 லேயர்ஸ்க்கு இடையில இருக்கக்கூடிய zone தான் discontinuity. அப்ப எப்போ அது discontinuity கன்சிடர் பண்ணுவோம்? 2 விஷயம். என்னோட seismic waves அதாவது படிக்க போறோம், நம்மளோட earthquake waves படிப்போம். They will change the speed. Mostly they will increase the speed. Change in speed னு பார்க்கறோம் இல்லையா? What happens to the seismic wave? They would increase the speed when they move from one layer to another with a higher density value. ஏன்னா we all know how the layers are arranged from the least to most. அப்ப மேல இருந்து உள்ள போக போக density increases. Density increase ஆகுற ஆப்ஜெக்ட்ல waves pass ஆச்சு அப்படின்னா அந்த waves ஓட velocity will also increase. அப்ப அந்த change sudden increase இல்லனா அந்த sudden change எங்க feel ஆகுதோ அந்த boundary தான் என்ன சொல்லுவோம்? Discontinuity ன்னு சொல்லுவோம். கண்டிப்பா லேயர்ஸே எந்த டிஃபரன்ஸ்ல தான் மேட் ஆயிருக்கு? டென்சிட்டி டிஃபரன்ஸ்ல. அப்போ ஒரு லேயர்ல இருந்து இன்னொரு லேயருக்கு அந்த வேவ் போச்சுன்னா கண்டிப்பா சேஞ்சஸ் நடக்கும். That is my discontinuity. And we have 2 important discontinuities, 3 important layers, so 2 different discontinuities. சும்மா for pictorial representation, if this is my crust, இது என்ன லேயர்? This is my asthenosphere. Then comes my mantle, then my core. Core, inner core, outer core nu refer பண்றேன். Not up to the scale, right? Crust, mantle and core, 2 important discontinuities dividing the crust and mantle. This discontinuity is known as Mohorovic discontinuity. Or simply Moho or M discontinuity, named after the discoverer, nothing more. Mohorovic ங்கிறது கண்டுபிடிச்சவரோட பேரு. Mohorovic discontinuity, Moho discontinuity, or simply M discontinuity, which separates what? Separate your crust from mantle. ரெண்டாவது என்ன? 2 important layers-ல this mantle and core இல்லையா? So mantle and core separate பண்ற discontinuity is Weichert Gutenberg discontinuity, or simply G discontinuity. So M discontinuity, G discontinuity. Whereas based on the density variation, crust is again divided into 2. crust is divided into two, outer crust, inner crust. Crust divide பண்ணுவாங்க, density variation தான், nothing more. So outer crust க்கும் inner crust க்கும் divide ஆகுற discontinuity is Conard discontinuity. எனக்கு M and G தெரிஞ்சிருந்தா போதும். Okay, whereas this is mostly prelims angle, other discontinuities பேர் கொடுத்து match கேட்கிறதுக்கான possibilities இருக்கு, கேட்டிருக்காங்க. Okay, so Conard அப்படிங்கிறது எங்க? Within the crust, இல்லையா? Outer crust and the inner crust. So mantle is again divided into two. Upper mantle, lower mantle. Words கொஞ்சம் important. This is my upper mantle and this is my lower mantle. Upper mantle and lower mantle. Upper mantle oda upper portions are molten in state and we identify that as the asthenosphere. Appo upper mantle, lower mantle divide பண்றது repeti. Repeti discontinuity. Obviously core, we have a well established difference, right? Outer core which is in a molten state and the inner core which is in a solid state. So this difference, this discontinuity is known as Lehmann discontinuity. Now, what is the current affairs? The mantle is divided into three sub-regions. Primarily, initially it was two. 2008 அந்த வந்துருச்சு, அந்த டாக் வந்துருச்சு. இப்பதான் the well established layer டிஸ்கவர் பண்ணிருக்காங்க. Very recently திரும்ப நியூஸ்ல வருது. So possibilities are there, we will get questions from these discontinuities. So இங்க two layers இல்ல, we have a three layers too. Marginல வேணா நோட் பண்ணிக்கோங்க, three subdivisions of mantle. Presently we have three subdivisions of mantle. Purely based on density difference, nothing more. On the rocks oda composition different, adanala density difference, adanala இன்னொரு layer அப்படிங்கிற மாதிரியான connotation, right? Density differences. Okay, so this is my structure. Structure la physical aspects therikanum, chemical aspects therinum. What are the different sources that we're going to elaborate next, and the different layers oda சேர்ந்து asthenosphere therinum and discontinuities therinum. Fine. Asthenosphere தான் உங்களோட magma chamber. நம்ம earth crustல பார்க்கக்கூடிய continentsல இல்ல oceanல பார்க்கிறது எல்லாமே எங்க இருந்து தான் வருது? asthenosphereல இருந்து தான் வருது. ஒரு சின்ன நோட் மட்டும் போட்டு எழுதுங்க, then we will directly move. That is, crust is divided into two. One is the continental crust. Continental crust and oceanic crust. Okay, so if this is my Sial layer, the crust is made up of two aspects. Right, so இது என்ன? This is my, நம்ம இவ்ளோ நேரம் diagram போட்டோம் இல்லையா, crust, mantle, core, இந்த மாதிரி concentric circles ஒருபோதும் இருக்காது. It is never concentric circles. The thickness varies even though they are sequentially arranged. Crust க்கு அப்புறம் mantle, mantle க்கு அப்புறம் coreங்கிற sequence தான் கரெக்ட்டே தவிர்த்து concentric zones கிடையாது. Right, so என்னோட continent crust is divided. This is my Sial layer or my crust. Okay, this is my Sial layer and this is my Sima layer, right? And the crust is divided into two. This land area is known as your continental crust and the land which has been submerged under water or submerged under your ocean is my oceanic crust. Okay, so we will make a simple comparison between my continental crust and oceanic crust. Which is larger? Which is a larger area? Continental crust or oceanic crust? Bigger, which is larger? Height adhigam. Yarukku height adhigam? Continents da height adhigam. Mountains da higher relief order. So in our mountains the larger body. So they are larger. Whereas they are larger, when I'm going to use the word, they have more thickness. Okay, and the oceanic crust are relatively thinner. Yeah, the thickness is relatively small when compared to my continental crust. Now comes the conceptual clarity, which is denser. Of course, Sima Sial compare pannona, which is denser? Sima. That is why it is sinking down and my Sial layer is floating over, or Sial layer is lying over Sima because this is less dense. Appo within Sial compare panna, continental crust divide pandrom, oceanic crust divide panna, which is denser? Oceanic crust is denser, right? It is thinner but denser. Whereas it is the thicker one but relatively less dense, comparatively less dense. That is why the ocean bed are sinking. The rocks are relatively made up of more dense elements than the mountains. Continents periya land mass madri theriyalam, ana avangala density koravana element, kammiyana elements. Ocean floor, they are more dense. So in the clarity theva, okay, they are thicker but relatively less dense. Yaru continental crust. Oceanic crust they are thinner and relatively more denser. Fine. Note we'll come back to these all concepts when we study plate tectonism. Plate tectonism we will understand why the ocean plates are easy to break away and all. Right? Anga the thirumba add on panikalam.